Alright, I shall begin with my lesson. Now today I'm going to go through a little bit on speed, distance and time and acceleration time graph. The commonly tested one is speed time graph. Then after that, second commonly tested is distance time graph. And then finally, sometimes they like to add on a little bit extension concepts to acceleration time graph. So now I shall begin with speed time graph. There are certain things that you actually know the relationship between speed and distance time graph. Number one, so what students usually know is that for gradient of distance time graph, gradient will give you the speed, right? Okay, so for gradient itself, gradient of distance time graph can give you the speed. Then what about speed? If I have the gradient for speed time graph, it will give you the, what does it give you? Nobody answer me, don't like that leh. Wait. Yeah, if I have gradient of speed time graph, then what will it give me?
Acceleration.
Yes, the acceleration. Okay. Then next thing for speed time graph relationship, okay, to the distance time graph, the area under the graph will give you the distance. That's easy, right? So most of you are able to do the question. But now we are going to explore a little bit more concepts on the speed time graph itself. What happens if they ask you using the speed time graph to find the speed? For example, find the speed when it's 16 seconds. How do I find this speed? Okay, and given this graph, there is two concepts. So if I want to first find the speed, there are two concepts to use. The first concept is that when this point here, right, that is on this line, they share the same gradient. Okay, that's the concept number one. What do you mean by share the same gradient? So what I can do is, this point over here is the point 0, 0. This point over here is 20, 10. What can I find from this line? I can find the gradient, correct? So the gradient will be how much? 10 minus 0, change in the height, divide by the change in the base, 20 minus 0. That gives you the gradient to be half. So if I want to find the speed, okay, at when it is 16 seconds, what do I need to do? I need to take the this point here. Let me erase this away. This point over here, this will be 16 seconds. I do not know the speed. I'll call it v. So 16v. So the next part is I'm going to link this to what is the gradient that I found just now. So if I were to use this, this will be speed v minus the 0 over the time taken is 16 minus 0. This is equals to half. I'm going to link these two gradient together because they fall on the same straight line. So when they fall on the same straight line, the gradient is the same. So if I were to do this, I can get easily the answer v to be, I'm going to multiply 16 across because 0 doesn't have any effect, right? So I multiply the 16 across, that will be half times 16. What is half times 16? 8, is it 8? Yeah, so the speed will be 8 meters per second. That's the first concept where I use the same gradient. Okay. Now I'm going to tell you the second concept. Okay, wait, have y'all finished copying first? Y'all want to copy first? Second concept is to use similar triangles. Okay, y'all write down your concepts first. Y'all write down first and listen and try to multitask at the same time, okay? So what is similar triangle? Where are the similar triangle? First one over here. What is this? This is your height of this triangle V, and the base here is 16. The second triangle, which is quite obvious, that is this one, the slightly bigger one down here, the height here is 10, and the base is 20. So using similar triangles, we should take height over height. I know there are a lot of you who wrote V over 16. That is not correct. It's corresponding size first. So it's V over 10 is equals to 16, the base over the base, 16 over 20. So height over height equals to the base over the base. Then if that's the case, I can cross multiply over v equals to 16 over 20 times 10. That will still give me the answer 8 meters per second. Is this okay? Okay, you all write down this concept first. You all are ready? Then I'll move on to the next part. Let me know. You no response one.
Okay,
Can done. Okay, now I'm going, after I done this, right, I done this part on the speed, right, I'm going to link back from speed time graph how to go to distance time graph, the one that is usually being that you all need to like draw the graph or whichever. Okay, now there are two types of distance time graph. I'm going to go down below already. Okay, there are two types of distance time graph we need to understand. The first type is distance traveled. If the distance time graph records the distance that is being traveled, there are a few characteristics. Number one, it is always increasing. Always increasing. ICSING. Oops. Okay, it's always increasing. Number two, there will be no negative value. Because it's always, distance is always positive, right? There's no negative distance. Okay, but there is a second type that can have different types, can have different values. The second type is called a distance time graph from a fixed point. So this is distance from fixed point. What do you mean by distance from fixed point? Now, recently this has been quite popular, meaning that, for example, I can have a Z come from the home, then another person maybe come from the what, I don't know what place, school, okay, for example, okay, there is two different position. So if I say this is the distance from the home, where that means home is going to be the zero distance, there's one person that can travel in this direction, they can go up to school. But if I were to have another person that is traveling in the opposite direction, then in this case I can have this person maybe start at a different timing, it travels down or whichever. So in this case, when you have this kind of distance time graph, where did my line go? Okay, the distance is not always increasing. The distance can change, can be increasing or decreasing, right? And usually we will still not have any negative value because distance will never be negative, but usually we need to take note of time points. The time frame. So what time is it started? What is the speed that is taken? Is it constant speed or is it what speed, whatever information they give? Then how do I draw this line? Which is the ending point? So usually they will test you on this kind of concept when you need to mark the time, then you draw and complete the distance time graph on your own. Okay, but now I'm going back to the traditional one. If let's say they don't give you these two type of distance time graph, they ask you to draw a respective distance time graph from, okay, a speed time graph. From the speed time graph itself. I'm going to go up here. So one thing about this, if this is talking about the distance time graph that is corresponding to the speed time graph, you notice that I split this up into three different portions, right? Why is that so? Because the timing, right, 20, 40, and 70 seconds must match. So when we have this kind of graph, right, they will always cut it into the different intervals to match. Okay, so now there are important things that we need to take note. For distance time graph, when you want to plot the distance time graph, number one, we must always indicate the total distance, not just only the distance within that time frame, but the total distance. We must make the marking for the total distance. Okay, and then we decide to draw a graph, whether is it a smiley face for acceleration. Is it too small for you? Okay, not enough space already. Sad face for deceleration. And then straight line for constant speed. Okay, so I'm going to use this example over here to show you how are we going to plot a distance time graph and make a sketch. I think most of you might have an idea, but just that you already forgotten a long time ago already. So what we are going to do is we are going to calculate the different distance for each of the component. Can you help me how to count the first part, distance on for the first frame here from 0 to 20 seconds? What is the distance? You all calculate. That will be area under graph, right? So half times base times height, area of triangle. What you all get? Don't like that lah. I know the answer, but then I need people to tell me answer. Hello? How much? Half times 20 times 10.
100.
Yes, correct. So this is 100 for this portion, right? Then what about the distance in the middle portion? What is the distance covered? This one is yes.
Yeah, 400, isn't it?
Is it 400? Check I only want this portion. 20 to 40 seconds.
Oh, 200.
It's 200. Right, then the last part, what is the distance at the last part? Half times 10 times 30 now.
150.
150, correct? Okay, thank you very much. Now, usually what the students will do with a common mistake is they will plot directly 100, 200, and 150 on their axis over here, which is actually not correct. Why is that so? Because this is talking about the total distance being accumulated. So if I want to mark a total distance being accumulated, when it's at 0, it will be at 0. When it's at 20, I traveled 100 meters. Okay, but when it's at 40, I do not only just travel 200 meters, I travel an additional 200 meters. So the time frame is actually from 0 to 20, I traveled 100 meters in total. But when it's 0 to 40 seconds, my total distance is now 100 plus 200, which is students will forget. Then they go and plot 200, then the graph will not look smooth. So it's actually now additional another 200. It will become 300. So 1, 2, 3. So 300 is here. Then you plot at this point 300. Then the last one, is it going to drop to 150? No, it's going to be from 0 to 70. I take 100 plus 200 plus another, the last timing, the last distance, 150. That will give you 450 meters. So the last one over here is actually 450. Then you mark. Okay, so you need these few important points to begin with. So now out of these three portions, right, which is the easiest to draw? The one that is easiest to draw is actually the constant speed. Why my highlighter didn't work? Okay, sorry. You all have your whatever coloring technique or whatever you all use, okay? Okay, so this portion is actually a constant speed. Now out of these three, I have acceleration, deceleration, and constant speed. What does constant speed, the distance time graph, look like? Anyone?
A straight line.
Yes, thank you very much. So going up, straight line. Okay, okay, my ruler doesn't, my ruler fails me. Can you all use ruler, please? I did freehand. Okay, let me try and use my ruler. Okay, so this is a constant straight line up. Ah, where did my lines go? Okay, so this is the straight line up. Then this portion is a straight line going up, no problem. But what about when I have a acceleration over here? This is an acceleration. Acceleration means the speed is increasing. What does that mean? It means in general, usually my gradient goes from what is being flat to a gradient that is steeper. That means the speed increases from something that is flat gradient to something that is steeper. Give me a minute. Oh yeah, this one, Mr. New. Mr. New call me. Wait, y'all give me a minute. Hello? Ah.你的 touchscreen 哈，哦，就是有可能 touchscreen 坏了咯，要见要见医生了，要去找 Iman 了。所以你的 writing 你用你的 stylus 不可以写啊？你 restart 了也不可以吗？你 restart 了可以吗？哎呦，因为他最近有 install 一些新的东西，可是我不懂他们为什么会突然间讲诶。then 你可以 I think 你要 try to the only thing I can suggest is you try to restart then after that you plug out you know 你是可以 plug out 你的那个 tablet 那个什么那个 keypad 的，你可以把它拿出来 then 你看它会不会变成 respond to such that 你需要用 stylus 和 finger 看你可以 try 吗？然后你再 try to 放回去 then 看可不可以。these are usual things I try to troubleshoot lah, but it may not work. Yeah, so that is on tablet mode. Then tablet mode they will need to sense your finger mah. Wow, then like that means the touch screen got problem already. Touch screen option got problem. You might want to see TA. Yeah. 就等你要用的时候就会坏了，就是这样啊。OK，谢谢你啊。OK，好，拜拜。Okay, sorry. Wait, where am I? Wait, can you hear me? Wait, did I switch off my mic just now? No, right? Oh shit, you all hear all my conversation, is it? Okay. So this one is a acceleration. So acceleration, right? This one will be from going from something gentle then to something that is slightly steeper. So this is a acceleration. So it's usually I say acceleration you pick up speed, right? So you drive in a Ferrari, you can chong on your expressway, so you feel very happy. So it's a happy face. Okay. Then now the next part over here, this one I think some of you also remember a little bit. Now this portion over here, I'm traveling downwards. This one is a speed, I'm reducing my speed. So it's actually a retardation, that's deceleration. So when it's a deceleration, what does that mean? Means my gradient is originally something that is very steep, then it now becomes something that is gentle. So when I have a deceleration, this is actually usually a sad face. Why I say it's a sad face? Because you go into expressway, you chiong very happy already, right? Then you see the policeman stop your car, then you need to come to a stop. Not straight line curve, okay? But my curve doesn't look very curved. Okay, yeah, you all need to make it more curved, okay? So you see the policeman already, then you feel very sad. Alamak, kena summon. Okay, something like that, okay? So it's a sad face. You all try to make it look as sad as possible, okay? But things that you need to take note when you draw a distance time graph that look like that, the connection point here, please do not draw those kind that looks like that. Okay, do not have those kind that looks like the sharp point. They should be smooth. Okay, because this is a gradual change over a period of time, it should not have sudden changes. So it should not look something that is a sharp corner. So even though your shape is correct, but it must look smooth enough to look like it's no moving on one full straight line. So this kind of corners, please avoid. Don't do this kind of thing. Okay. So if you have done this portion, I'm going to teach you something a little bit extra. Not frequently tested nowadays. Okay, but you never know. It's still inside your syllabus, so can come out anytime. Now I'm going to teach you about acceleration time graph. Actually, I think most of you might have known a little bit, but not you don't get to practice it very much because even in your T1S it's also very little questions. So now what we are going to do now is we're going to find a gradient, the acceleration. Can you find the gradient for the first portion? Actually, I found the gradient for first portion. The first portion here, the gradient is, the acceleration is 10 divided by 20, which is half, right? So this is a positive acceleration. But at the middle yellow color portion here, is there any acceleration?
No.
No, don't have, because it's constant speed, right? So don't have any acceleration. What about the last portion? The acceleration is,
Negative?
yes, the acceleration is negative because it is deceleration, right? Yeah, my ink pen is negative. This one will be how much? Y2 minus Y1 over X2 minus X1. Your count. If not, you use the point 40, 10, 70, 0. Then you count the acceleration. I do mentally is 10 divided by 30. Is it 10 divided by 30? 1/3. Negative 1/3. Is it negative 1/3? I think so. Because the height is 10, then the base is 30 height divided by base. So 1/3, correct, but it's negative, right? Okay, never mind. I do mental science already. Correct. So now how am I going to draw this on my acceleration time graph? Okay, on my acceleration time graph, that means I'll need a few particular values. I'll need the first one, that is half. Then another one is 0. And the next one will be negative 1/3. Now this type of graph is called a stepped graph. Okay, because they looks like steps, but they do not join together because the acceleration over for this kind of graph changes suddenly. So it's what it's going to look like. It's going to look like one straight line from here to here, then 0 to 0 speed, then after that look like that. They are not connected. Take a look at this portion over here. Do not connect them with a straight line. Okay, do not connect them with a straight line. So this portion is supposed to be empty. So do not connect them to a straight line. They look like a flight of stairs. Okay, they are not connected. Why? Because we are changing the acceleration suddenly from one point to another point. So it's not joined together. So this is called the acceleration time graph. So we also know that when you have a negative acceleration, this means this is equals to positive deceleration. What is another word for deceleration? Starts with R.
Reduction.
Not reduction. Retardation.
Retard.
Yeah. Why you scold me? Okay, wait, I don't know how to spell it. Retardation. Okay, yeah, retardation. So when you have negative acceleration, it is supposed to be positive retardation. So if the question asks you to find the retardation or find the deceleration, you find the gradient already, right? Remember to change it to positive. Okay, but if they already say find acceleration, then you can leave it as a negative number. So this one you must remember to change the sign to negative number. Okay, so with this I finished. Actually, I summarized all the important concepts that you might actually need. The other concepts, I think you all can do it on your own. So I'm going to end off my lesson for today already. for this part, I will strongly encourage you to do the quiz paper, not quiz, the homework that I gave you. This portion, right, you need to use this concept, the one on same gradient, similar triangle, and you need to use a little bit of this concept. You need to do the drawing, and remember to calculate the total distance. Maybe I should put total distance with a bling bling. Yeah, total distance, you must use total distance. Okay, you must use the total distance. And then given your scenario kind of question, especially this type, fixed point. Okay, these are the namely the main field that likely is going to come out, be tested lah. Okay, then you all finish up your worksheet. Tomorrow I'm not in class. Okay, I'll be giving you a algebra worksheet and some TYS questions that is related to shapes and solids. But I'll have a video that goes through the paper, the paper itself. If you do not know how to do, you can watch the video as well. If you know how to do, you finish already, then you check the answer. And then this answer will also be posted for the quiz question. The not quiz question, the remedial paper, the answer will be posted also. So y'all can go online and check. If the teacher don't allow you all to use video in class, please let me know. I'll message the teacher. Okay? Can Okay. Anyone need anything? Do you need me to post this whole thing on Google Classroom as well?
Yeah. So,
Yes.
if the teacher don't allow to use phone, how to tell you?
Ah.
Yeah.
Can lah, you secretly, y'all not, I thought y'all very good at it. Y'all don't fake but I got right in my relief form say watch the video, okay, because tomorrow I'll be in school until 11:55. So if I get to know who is my relief, I will inform the teacher, okay. If not, then okay, I don't know, but yeah, go Google Classroom or whatever. Can? Yeah, can lah. Y'all try ways and means, okay. Bye bye. Yes.
My mom gave you her result.
Oh yes, thank you. Yeah, bye bye. Bye. Okay, I'm going to post this on Google Classroom. Y'all can check further. Bye. Y'all should be going off now. Bye. Why nobody? Hey, hello. These few people. Y'all, why y'all don't want to go off?